All right, if you didn't get stumped on this, you win the prize because this is supposed to stump you. It's a hard problem. Some reminders. Up here, I can't find my mouse. There it is. Okay, up here is a voltmeter. Over here is an ammeter. Okay, ammeter measures current going through there. Voltmeter is going to measure the voltage difference an electron would use up going from one side to the other side. All right. So I have here a resistor here and a pair of resistors here. So I told you the strategy starting number one is find the total resistance. What is the total resistance of the circuit? So I take a look at this and go, well, if I'm a positive flow of electron, no, I'm going to use an electron. If I'm an electron, I can either go this way or this way, right? Those two are in parallel then. I'm not going to go backwards through one, so I'm not forced to go through both of them. I'm only going through one or the other, so these are in parallel. So these two right here are in parallel. Okay? Once I come out of the back side of this, though, I have to run into this. Do I have a choice? I could go through the voltmeter, but if the voltmeter is set up properly, it ain't going to matter, right? It can't change your data. You want meters that change your data. So the bottom line is that can't stop what's going on here. So the bottom line is this, and then it has to go through this resistor, then back to the battery. So this is in series with the other two, correct? So what I'm going to do is I'm going to lump these up, and I'm going to say this is like one resistor, R total, 1 over R total equals 1 over R1 plus 1 over R2, which means that I'm going to get 1 over RT is equal to 1 over 20 plus 1 over 30. Now again, this is a physics class, not a algebra class. So what I'm typing into my calculator right now is 1 divided by 20 plus 1 divided by 30. And then I do 1 divided by shift answer, and I'm going to get myself that the total resistance of this is, resistance total of this is 12 ohms. So since this is 12 ohms over here, this is 12 ohms over here, the total resistance is going to be the 12 ohms going through this thing plus another 10 going through that one, which is a total of 22. I'm going to find my pen. 22 ohms. All right. So now that I have 22 ohms of total resistance, I can figure out how much current's coming out of the battery. How do I do that? I do that by doing the following. I go voltage total equals resistance total plus current total, right? V equals IR. So we're going to treat this as one big 22 ohm resistor to get back to the battery. So because of that, I can do the following. I can go, I lose up 100 volts going through a total resistance of 22. What is my total current? Okay, so 100 divided by, 100 divided by 22, and I get 4.5. I get IT equals 4.545 amps. Okay, so now I come back over here and I realize what's total current being drawn from the battery? Well, 4.545 amps or 4.55 amps is what the answer is. So that's what's coming out of the battery. So I got 4.55 amps going that way. So next stop, as we were walking around the thing, it goes to the ammeter. Ammeter can't affect anything, but it measures how much amperage is going through there. How much amperage is going through there? Well, that would be 4.55. That's two answers. Two out of the whole. Now I got problems coming because it says, what's the current going through each of the resistors? So in other words, what is I1, I through 2, and I through 3? Okay. Well, now as I turn the corner head this way, I note, all of it has to go through that resistor, assuming the voltmeter is doing what it's supposed to do. So therefore, all of it is going to go through that 10 ohm resistor. So I know I must have, here it is, find my pen. This is great, 4.55 amps. Unfortunately, I don't know these two. That's a bummer. Well, can I solve for what the voltmeter reads? Yeah, sure. If I've got V equals IR going on over here, V equals IR going over here, then my voltage is equal to, I'm running 4.55 amps through a 10 ohm resistor. I'm losing 45.5 volts. Okay, so the voltmeter if an electron is here, it has to get over to here, which, by the way, is backwards, but we don't worry about that too often. If it goes through there, it's going to burn up 45.5 volts. Or it has to do that going through the voltmeter. Okay, so therefore, my voltmeter is going to read 45.5 volts. Now that's real handy because, and I got to look at the back side, I have a problem. I don't know how to do this parallel. I don't know how much current's going down each route. I know 4.55 is going into it. I know 4.55 is going, 4.55 amps is going that way, but I don't know how much goes down each path. And the answer is simpler than that. You look back and go, well, gee, the voltage left over. What is left over going from here to here? How much volts do I have to use up getting from this point here to this point over here? Well, I started with 100. I've used up 45.5. So there must be 54, where's my pen? 54.5 volts left over. And if that's the case, then I can figure out the current through each of these by simply going V equals IR, because both things in parallel are going to use the full voltage, right? So I'm going to get 54.5 volts is equal to the current, which I don't know, times 20. And I quickly run my current through that. I go 54.5 divided by 20, and I get 2.73 amps. Now I'm going to try the other one. I go V equals IR. My voltage is 54.5. Again, I'm using the full voltage because an electron, whether it goes this way or this way, has to use up all its voltage before it gets down to here, because the rest of it's just straight back to the battery. All right? And so I don't know the current, but the resistance is 30, right? So 54.5 divided by 30, and I get then my current. My current is going to be equal to 1.82 amps. Now, these two must add up to the current 4.55 going in, right? Because if part is going one, part is going that way, those two added up together better be 4.55. So I might quickly add these up, plus 2.73, and I get 4.55 amps, which makes perfect sense. And so now I know, and for my final answer, I know that going through I2, I have 2.73 amps, and going through I3, I have 1.82 amps. And those two add up to 4.55 amps. I note that I lost 45.5 volts going through the first resistor. I lose another 54.5 going this way. I am good to go. Done. Okay. All right, so that's how you do problem number 1. Try problem number 2, a video for that. When you get done with number 2, try problem number 3, and that is going to be your homework. So, tra-la, and then we'll pick this up next time, hopefully.